Inverses. You need to know inverses in 3 different ways. First one is a table. That's the easiest one. You have a literal box of numbers, x's and y's. You switch x and y, that's an inverse, done. The second thing is a graph. Being able to see a graph, take the inverse of the graph. There's one extra thing. Again, you still are switching x's and y's. But the third and final thing that you already know is how to take the inverse of an equation with this, switching x and y, solving for y, all that stuff. So today's entire thing is graphs. So on your paper that you have right now, flip it over to the back side. We're going to start off with this one right here. You will see there's another graph right here, right? I'm going to show you how that graph came to be, and then you'll just, inverses will make a lot more sense that way. In fact, this is the only thing I'm talking about, inverses of graphs, so if you're going to pay attention to anything that this whole week, this is the moment, right? I have all of these points. If I want to take the inverse of a graph, usually on a table you have the points and they're said x, y on a table. Here I have a bunch of points and they're said on a graph. So I'm going to pick my favorite point, which is going to be this one. What's special or unique about that point? It's so special and unique it has an actual name.
What is it?
Vertex, very nice. Yeah, that is the vertex of a quadratic. It's the very bottom point, the very top point. It's where it changes from one direction to the other, highest value, lowest value, whatever. Okay, that's the vertex. I'm going to inverse every point here, but I'm going to start with the vertex, and maybe you'll see why in a second. So this point is -3, 2. -3, 2. If I were to inverse that point, it would be
2, -3.
2, -3. So I graph that point, 2, -3, and we're down here now, right? As you can see, it went from here to here. Now that might not be enough information for you to be able to be like, oh, that's what it is. The light bulb should go on here in a minute. But that point is now there, inverse, okay? Now, so here's some little clues here. Let's try out another point. This is not on your paper, but just pay attention to this part. I'm going to graph this point right here, okay? That is -1, 2, 3, 4, 5, 6, 7, 8. That is -8, 0. What is the inverse of that?
0, -8.
Okay, very nice. 0, -8, and we're down here, right? Okay, so that point went to here. Maybe you could start to see a pattern of what's happening here. I'll do one more to see if you can catch on to what's happening. And then I'll ask some questions. 1, 2, 3, 4. Let's do it right here. We're going to put it on the y-axis right there. Inverse of 0, 4 would be, yes, 4, 0. So 1, 2, 3, 4, 0, right? 0, 4 turns into 4, 0. And I'll ask this question too. This might make sense too. I didn't say this the last class. What axis is this?
Y.
It's sitting on the y-axis, and then when you inverse it, it's on the x-axis. I was switching it to see the big picture. Okay, so now I'm going to do something. I want to see if you notice something. This point got put to here whenever I took the inverse. This point went to here when I took the inverse. Keeping the colors going. This point got to here. So how would you describe an inverse? I like reflection, and I'm going to put a big thing right here. Inverse, you write this down in your paper too. Inverse is when you reflect over, does it reflect over the x-axis? No, wait, no. I like that you said yes and then caught yourself. That 4, if I reflected over the x-axis, it would be here, right?
Yeah.
If I folded like a piece of paper, like, whatever, hamburger style. If I folded it like this, it'd be down here. Does it reflect over the y-axis? Ooh, wait, no. Okay, so I like that again. Good job. If I reflect it over the y-axis, this thing, right, it'd go from here over to here. So it doesn't do either of those. Some people like to say, oh, it reflects over both of them. Okay, it reflects over. It's hard to draw this, so. Ooh, look at that diagonal line. Okay, it reflects over that diagonal line. Do you see them literally reflecting over that diagonal line now? That's why I draw the little, imagine like a piece of paper, you have folding it along a diagonal, okay? So if I put something way out here, it's gonna go way out here. If I put something really close right here, it's gonna go really close right here. It's literally like a mirror, a reflection, okay? Over y equals x. That's very important, that's a test question. Okay, it does not reflect over y, it does not reflect over x, it reflects over the diagonal line, y equals x, okay? Cool. So I have my vertex point right here. Now let's graph the rest of these so you can see what it actually looks like. I know it's on your paper and stuff, but here we go. This point right here is -2, 3. -2, 3. I inverse that to be 3, -2, and we're right here. Right? I'm going to do this other point over here, and which is -1, 2, 3, 4, 3. So -4, 3 turns into 3, -4, and we're here now. Right? Now I want you to see this. I'm going to put a little star on this point right there and a star on this one right here. That's the vertex, right? And make sure you want to keep track of the vertex because it's a lot easier to draw this stuff when you know where the vertex is at, right? So this is what I've got so far, right here. That is this, right? As far as what I've drawn so far, okay? 2 more points left. You might be able to kind of figure out where they're going, but that's -1, 6. I'm going 6, -1. What? Yeah, 6, -1 right here. Boom. Right? And then I got -5, 6. I'm going 6, -5. And we're here. Okay? Now, on your paper, here's another way to test to see if it's visually symmetrical. On your paper, you could literally hold it like this, right? Just hold it diagonally and you can see it a little bit better instead of cocking your head to the side. You can see that it literally, if I fold it in half, it'd be touching each other, right? It'd be like, you could literally do it yourself. And I've seen tests that usually score pretty high where people literally are like, oh, okay, I see it, right? So biggest thing, and this comes into my gotta stretch for this. I'm getting a little old for this. I'm a quadratic. Do you see me? You see the quadratic? Right? If I reflect over the x-axis, that is like this, which is not what happens, right? If I reflect over the y-axis, it does this. That's not actually what's happening, okay? I'm reflecting diagonally, right? Okay? This is gymnastics, or not gymnastics, aerobics, I don't know. I'm reflecting like this. So I want you to see if you can catch this. Right here, this point, I'm going to circle it with a green marker, okay? This point is the same as this point, right? The inverse. You got to make sure that you can match up. On your paper, it has letters and stuff that you'll have to answer. But I'm going to use my hand real quick. Right here, my fingertips are where this green arrow is. Did this graph do this? No. See what I'm saying? Watch. Because if this green arrow is right there, if it did that where my thumb is, watch. Is it here? No. So it's not a rotation. It's not a spin like that. That's why I'm talking about this. That's why I'm doing these freaking aerobics up here in this spinning motion. So watch what happens. This is what it is. It's next to my fingertips. Whenever I reflect it, it folds over, and it's right here, right? And it's still in the same spot. So it's this flipping situation. Okay, diagonal reflection. All right. Anyway, there's that. Now, the next problem you have right below that, it has this line right here with the points on it. What do you think you're going to do with each of those points? Inverse, switch them and graph them. Done. Right? And that's literally it. I'm not even going to spend time on that one. It's a literal line. Graph the new line. Done. But the most important thing, or the final thing, is the first side. So flip back over to the front side. It has a graph graphed, and it graphs another one and says, are they inverses? Right? I need you to be able to do this in 2 ways. One, mathematically look at the literal value of the numbers and see if the numbers are switched, right? We had -3, 2, 2, -3. Yes, that's good. But then also, I want you to be able to visually take a step back and be like, yeah, that's an inverse. And you should be able to tell really quickly with looking. So right here, they gave us something that looks like this. Where'd marker go? Oh, here we go. They gave us something that looks like this. Is that an inverse?
No.
Not even close. It's not even the same parent function, right? That's a line, linear line, and that's a quadratic. X squared, no. So that is not an inverse whatsoever. But what I do like that they followed it up with is this. They gave you an actual, this would just be no as far as the paper goes. I want you to watch. I'm going to draw this. This helped some people last time. So I'm going to draw this frame by frame. I want you to watch this happen. So this is the parabola. I'm going to inverse it over this diagonal line right here, right? So here is going to be here, right? So see it happening? See what I'm saying? I don't know if that visually kind of helps a little bit, but I'm here, we're going sideways, right? And it's that that pivot of that fold over. If I literally had like a piece of paper and made a lot of ink right here, folded it over, there'd be an impression or a stamp, right? Whenever I flipped it over, okay? That is an inverse. And if I kind of look at it, oh, it looks symmetrical, right? My final analogy here, and this might help, is if I had a smiley face here, I know you're never gonna graph a smiley face. It would not look like this. See what I'm saying? See how that would be like sliding down? If I folded this over and reflected it like a mirror, okay, it would look like this, okay? This close smiley face that's close to this would be reflected right here, right? And then you'd have your smiley face. See if I fold it in half like a piece of paper, okay? Cool. Then the last one here is a little tricky. It's the last final curveball, is does this, what they drew here, they drew this thing here, is that an inverse? I like that you're pausing because it should be somewhat confusing. Is it an inverse?
No.
Okay, I agree with no, because here's why. Is it symmetrical?
Yes.
Yes, it's symmetrical. It looks nice and symmetrical. Cool. I see this personally as this folding across the y-axis. I see it as like folding it this way. So this folds across this way, this folds across that way, like this. That's what I see. Somebody last class or whatever said that they see it, this folds down there and this folds up. That works too, right? Either way though, it's not an inverse, because an inverse is when you reflect it across diagonally, right? So if you don't understand the visual, here's the math numbers of it. Like I said, you need to know both. On your paper, I really want you to look a little closely, and this is a tip that I would give you, and the last thing I'm talking about. I want you to look at this point and pick a point here somewhere and reflect that point, or sorry, inverse that point. So I want you to see at 2,5, at 2,5 is the line exactly at 2,5. It is not exactly at 2,5, but is it close enough for us to learn something from? I would say yes. So here's what I would do. I'm just gonna estimate that this is 2,5, 2, 5. So if I inverse that, it becomes 5, 2, and it's right here, which makes sense because it's a diagonally reflecting across, right? Folding across. So this swoosh would be this swoosh, right? And then if I pick this point over here, right, and picked another one, because some people like to do this or something, or they don't know where to send it, because if you get confused or whatever, pick a point so you know where to go to. This point on the original brown graph, that is -2, -5. So instead of going -2, -5, I'm going to go -5, -2, and we're here. Which should make sense because the graph should come in and swoosh like that, right? So the swoosh, and if you look at it, reflecting, take a step back, it's diagonal. Okay, cool. Okay. The answer to this question, though, is if these are inverses. The answer is no. So just say no, and I just want to take it a step farther right there. Okay. And that's it. Cool. Done. Boom.